Hello, welcome to my channel RN Dosage 101. So the purpose of these videos is to help current nursing students or pre-nursing students understand how to calculate dosages. And the method that I use to teach this is dimensional analysis. And you will encounter a variety of questions in your dosages exam. For example, there's drip factor, PO meds, IV meds, infusion rates, total infusion time, conversions, weight base, safe dose range, body surface area, and input and output. So measures to know. Important measures to know are those in the metric system, for example, milligrams, grams, kilograms, milliliters, and liters. The household system, you have ounces, teaspoons, tablespoons, and cups, and drip rates. With drip rates, usually you will have, the question will tell you what is the tubing available. It could be 10 drips, 10 drops per milliliter, 60 drops per milliliter, 15 drops per milliliter. So always refer to your nursing school guide or syllabus that they tell you what they consider macro and micro drip rates. And also there's the grain measurement is where 1 grain is equivalent to 60 milligrams. So common conversions, these are the ones that you should memorize or learn. There's 2.2 pounds per kilogram, 1,000 milligrams in 1 gram, 1 milliliter is the same as 1 cc, 1,000 micrograms equals 1 milligram, 1,000 grams equals 1 kilogram, 1,000 milliliters equals 1 liter. And then you have the teaspoons, which is 5 milliliters, and one tablespoon is the same as 15 milliliters. 1 ounce is 30 milliliters and 1 cup is 8 ounces. So what is dimensional analysis? Dimensional analysis is a technique used to solve equations whose quantities have a relationship. And I have broken this down into 5 easy steps. Step 1 would be to find a unit of measure that the question is asking for. So you read the whole question, it's usually at the end what they are asking for. Step 2, you look for the quantities that the problem provides. Step 3, you find the conversion factors needed to solve the problems. With some problems you need conversion factors, with others you don't. And step 4, you set up and solve the equation. And then step 5, you double check your setup and make sure your answer is reasonable. So here I have a practice problem. And it is how many seconds in 3 hours? So what is the question asking for? Step 1, it is asking for the seconds. Step 2, what quantities does the problem provide? The problem provides 3 hours. Step 3, find the conversion factor needed to solve the problem. So the conversion factors for this problem would be that 1 minute is 60 seconds and then 1 hour is 60 minutes. So then we set up and solve the equation. So the way we set this up is on the left side, you put what the question is asking for. So it is seconds. And then you move on, and right next to the equal sign, you put your values that you have found in step 2 and 3. So one of the conversion factors is 1 minute equals 60 seconds. So we have seconds here, and right next to it, to the equal sign, you should have seconds there too. So we would place 60 seconds over 1 minute. And then we insert the next conversion factor. 1 hour is 60 minutes. So how would you set it up? Well, you look what you have down here, and it's minutes, and right across from it, you need to have minutes. So 60 minutes in 1 hour. And then the next, well, you don't need a conversion factor. The next piece of information that you need to plug in is what quantities were you giving. So you were given 3 hours. So you would set this up by putting the 3 hours on top because it would be right across. And you set it over 1. And then you would go ahead and cancel out your units. So I do this by, so we have minute here. These cancel out. Hours and hours cancel out, and you are left with seconds, which is what the question is asking for. Seconds. And then you would go ahead and solve. 60 times 60 times 3 is 10,800. 1 times 1 times 1 is 1. And then you would go ahead and do this, but the number divided by itself is the same number, 10,800. And then you would plug in the unit of measure that is for the answer. So they were asking for seconds. And that is how you set up dimensional analysis. And the answer for this problem is 10,800 seconds. So here's a practice question. It is Tom weighs 130 pounds. What is his weight in kilograms? So let's start with step 1. The question is asking you, what is his weight in kilograms? So kilograms is what the question is asking for. Step 2, what quantities does the problem provide? The problem is telling you that Tom currently weighs 130 pounds. Step 3, do you need a conversion factor? Yes, you do. So 1 kilogram is 2.2 pounds. Now step 4, you set up and solve the equation. So let me get my pen here. So the question is asking for kilograms. So we put that right on here on the left side, kilograms. And so you plug in all your values. We know that 1 kilogram is 2.2 pounds. So we put kilograms right across, not right across, but right next to the equal sign. It would be the top value because they have to match. And underneath it, we have 2.2 pounds. And then you plug in your next value. It was 130 pounds. So Tom weighs 130 pounds. So the pounds go up here because it has to be across from what is at the first value. And then you put it over 1 because so it won't just be empty there. You could get confused. And then you multiply right across. 1 times 130 is 130. 2.2 times 1 is 2.2. And then you plug it into your calculator and you get the answer. The answer is going to be 59.090 in more decimals. So like I mentioned before, with what I was taught is that kilograms get rounded to the nearest hundreds. So the 0 here would make 59.090 round to 59.09. And that would be your answer for this problem. And also we want to double check the setup and make sure that the answer is reasonable. So we would do this so we can basically do the problem in reverse. So now we're going to figure out how many pounds are in 59.09 kilograms. And so we know that there are 2.2 pounds in 1 kilogram, so we just multiply 59.09 with 2.2 and it equals 129.998. So remember, we round to the nearest whole number with pounds, and it would round to 130, and it is exactly what Tom weighs, 130 pounds. Okay, so that's the end of this video. Don't forget to like and subscribe, and for the next one I will give an example solving a medication dosage. For example, you could have let's see, the physician orders 600 milligrams of ibuprofen PO in 1 day. The pharmacy supplies ibuprofen in 300 milligram tablets. How many tablets do you give the patient? So this would be easy. It would be 2 tabs. 600 divided by 300 is 2. But I will give a more complex one. And then I will also be releasing a short course that contains practice problems and step-by-step instructions on how to solve them. So stay tuned and don't forget to follow me on Instagram. Here is the Instagram profile. It's RNDosage101, and thank you for watching, and soon I will also post more videos with more complex problems, so stay tuned.